Hello, my name is John Riley. I'm a technical marketing engineer here at Samtec. Today we are going to talk about solutions that are available at 112 gigabits per second, trends we are seeing, and then walk through some active demonstrations that we showed at the DesignCon live event in San Jose. This will be a bit different of a webinar in that we will pull in other Samtec system engineers as well as share some of the content that we have worked on to really deep dive the pieces of the channel around 112 and beyond. DesignCon attendees typically look forward every year to catching up live with our Samtec geeks, our technical experts and engineering leaders. This virtual show brings some of that to the designers over this 2-day period. With Geek Speak, Samtec created a continually growing environment over the past year where we take topics typically only shown during technical forums to an on-demand library of topics around designing systems at 112 and beyond. We understand that since many engineers and SI experts are still work from home, they still need to keep their skills sharp. Samtec's Geek Speak Zoom webinar series allows engineers to interact with Samtec's engineering leaders and SI experts. The most recent Geek Speak is on key development steps of 112 gigabits per second PAM4 test platforms. With great gigabits per second comes great responsibility in tuning your design. Our signal integrity experts also presented this paper going through multiple case studies with root cause analysis on findings using some of our active demo platforms. Some of the findings highlighted the attention to detail and how sensitive the system becomes as speeds increase. A lot of this comes from exercising the fundamentals learned in school to tightening the controls and tolerances used. Samtec develops these active systems to push the limits of our connectors while working with our silicon partners, as they develop the next generation chips at higher speeds and higher data rates. Let's take a look at one of these demos. This first demo features a high-speed cable system which enables 112 gigabits PAM4 signaling. This can be used in a midboard or midboard to front panel or even panel-to-panel applications. This video is from DesignCon 2021 Live. This product is Samtec's NovaRay flyover cable system. It's operating at 112 gigabits per second PAM4. It's also using the Bullseye high-speed performance test cable system. It's all driven by a Xilinx Versal Premium GTM transceiver. Let's go to Ralph Page, System Architect at Samtec, to walk us through the signal path.
Hi, I'm Ralph Page, Systems Architect at Samtec. I'd like to show you a very cool demonstration here at DesignCon 2021. It features a Samtec NovaRay flyover cable system operating at 112 gigabits per second PAM4, as well as a Bullseye high-performance test cable system. It's all driven by a Xilinx Versal Premium GTM transceiver. The Versal Premium ACAP allows vendors to position their network systems for 800G and beyond. The Xilinx GTM transceiver generates 2 lanes of 31-bit PRBS data at 112 gigabits per second PAM4 data rates. The signal travels from the B70A through 12 inches of low-loss microwave cable and is terminated to Samtec Precision 1.85mm compression mount jacks. These 1.85mm compression mount jacks are mounted on a Samtec SI evaluation board. The SI evaluation board fans the signal out through a 2-inch trace to the solder ball termination of a Samtec NovaRay connector and cable assembly. These are the NVAM-C and NVA-C series respectively. Signals then route through 1 meter of 34-gauge high-speed ultra-low skew 2NX cable to a second NovaRay evaluation board to N2 of the NovaRay cable system. The signal exits that board through more 1.85mm compression jacks, back to the Bullseye test point connector and back to the Xilinx Versal ACAP. The results are really excellent. Let's take a look. The bit error rate is amazing, e to the -8, that's no FEC. Especially taking into account that's 40 dBs of insertion loss die to die. Of course, the Samtec cable assembly accounts for less than 12 dBs, even at a meter long. The total signal path length equals 72 inches or 1.8 meters with 6 interconnect transitions. Nova systems combine extreme density and extreme performance, which is obviously critical as system size decreases while speeds increase. If you want further information or you have questions, please contact us at sig@samtec.com. Thanks for your time and thanks for watching.
Samtec uses many twin-X cables to increase the reach and improve the losses in the system. This is one of the best ways we've seen to go faster and farther. Samtec's differential cable is co-extruded for low intra-pair skew and the best control of the signal path, where 1 inch of PCB trace may contribute to about 1 dB of loss. The same length of twin-X will only contribute about 1/3 of a dB of loss. Samtec has been working on this cable and combining it with our connectors for many years now. We have a multitude of Samtec flyover systems for both inside the box, chip to panel, and now even outside the box solution. Let's take a look at another demo at 112 that takes that same NovaRay cable to the panel and extending farther with a fully shielded external cable. In this next demo, Jean Rimet, system engineer at Samtec, walks us through the signal path and discusses the system performance.
Hi, I'm J.R. Bonnefoy, a system engineer at Samtec. Today I am at DesignCon 2021 in Samtec booth. We are going to look at a live demonstration showing how Samtec flyover twin-X cable assemblies allow designers to extend signal reach and density, enabling 112 gigabit per second PAM4 performance. Let's begin by me showing you the signal path, and then we'll check out the performance of the channel. It all begins with AlphaWave's AlphaCore multi-standard SerDes, which generates PRBS31 data at 112 gigabit per second PAM4. These signals travel from the silicon through about 1 inch of differential traces in iTera MT40 material to a Samtec Bullseye high-performance test connector system located opposite the chip on the back of the board. The signals travel from the Bullseye system connector through 20 inches of low-loss microwave cables, which terminate to Samtec Precision 185 connectors. These 185mm Precision RF connectors are mounted on a Samtec SI evaluation board. The signals travel through another 2 inches of PCB trace to the solder bolt termination of a NVAM-C connector, which is a Samtec NovaRay high-density board-level connector. A NovaRay cable assembly, an NVAC P series, mates with the board-level connector and carries the signal through 6 inches of 34-gauge high-speed ultra-low skew twin-X cable to the panel mount interface. The fully shielded NovaRay I/O cable assembly, the NVAC E series, plugs into the panel and moves the signal through 2 meters of 28-gauge high-speed ultra-low skew twin-X cable. The signal goes back through a second port on the panel to another NVAC cable with an additional 6 inches of ultra-low skew twin-X cable and back to a second SI evaluation board. This demonstration has 8 different interconnect transitions and runs 3.5 meters. But the total loss for the entire signal path, including all cable assemblies and PCBs, is approximately 35.7 dB at 28 GHz. Using AlphaWave's user interface and analysis tool, let's take a look at the performance of this channel. We can see the eye diagram captured at the receiver after equalization. The margins are wide. The vertical bastop is showing the bit error rate for all 3 levels of the PAM4 signaling. The bit error ratio is calculated around 1e-7 for this long reach channel. The performance is well within specification by several orders of magnitudes, providing the designers plenty of margin. The histogram plot and the scatter plot shows the probability density estimate of the PAM4 signaling, showing really good separation and signal-to-noise ratio. As the data rate requirements increase, the system designers struggle with propagating these signals through lossy PCBs. Samtec flyover solution allow them to extend the signal reach and density by routing signals via ultra-low skew twin-X cable instead of lossy PCBs. If you have any questions about this demo, please email us at sig@samtec.com. Thanks for watching.
Not all demos we create at Samtec involve cable. Samtec got its start more as a board-to-board connector company. That's really where we want to start all of our systems, at the pins and plastic level, then extend our reach where needed with the cable, or even active optics. When designing a 112 gigabits per second system, or really any system for that matter, the mechanics of the connector play an important part of moving the signal from the host to the module or the chip to the panel. As noted earlier, the fundamentals of the design are still there. It is the tolerancing and attention to detail of the transitions that will get you if you're not careful. One of these newer connector systems is called Accelerate HP. This is a 0.635 millimeter pitch array that is designed for 112 gigabits PAM4. The extreme performance in an open pin field design. This design uses a BGA style termination with what we call our edge rate style contact. Both of these features can keep the signal path as clean as possible. The BGA or the solder balls remove the traditional J-lead solder joint and take the signal straight to the solder pad. The edge rate contacts are designed and tuned to reduce crosstalk and interference from adjacent signals. The combination of these two features in an open pin field allows for ultimate design flexibility where you can run differential pairs, single-ended signals, power, and ground scattered all around the connector to make your system routing how you need it to be. This is a bit different than the NovaRay systems in the first two demos. The NovaRay has dedicated grounds fully surrounding the differential pairs. There is development in the works for mixed signaling in the NovaRay, but running it differentially is the sweet spot for now. Not only is this next demo an open pin field, this is also right angle orientation. This is not always the easiest to accommodate at the 112 speeds due to the extra steps and bends in the pin stamping. The test setup emulates real-world high data rate applications by routing differential pair signals from the Synopsys device through the Accelerate HP high performance array. Let's check back in with Ralph Page to walk through this demo.
Hi, I'm Ralph Page, Systems Architect at Samtec. I'm at DesignCon 2021, where we have a number of really interesting demonstrations. This one in particular is gaining a lot of interest. In this new 112 gigabits per second PAM4 product demonstration, Samtec marries an SI evaluation kit for the new Accelerate HP interconnect system with a Synopsys 112 gigabits per second PAM4 transceiver test chip. The test setup emulates real-world applications by routing differential pair signals from the Synopsys device through the Accelerate HP high-performance arrays. QPBRS31 data travels from the Synopsys transceiver through about an inch of trace in an ITERA MT40 PCB to a Samtec 70 GHz bullseye high-performance test system. This is the Samtec BE70A connector set. The signals travel through 6 inches of coax cable to 1.85mm compression mount jacks on the first SI evaluation board, and then through 2 inches of trace to a mated set of right angle or 90-degree Samtec Accelerate HP connector system. These are the APMX6 vertical array and the right angle APF6 socket array. The signals then exit the second PCB through 1.85mm compression mount jacks through another 6 inch of coax cable back through the bullseye and then return to the Synopsys transceiver test chip. The results are impressive. The overall channel loss is 32.5 dBs at 20 GHz. Of course, the Samtec evaluation platform accounts for only a few of those dBs. The eyes are wide open, and the pre-FEC bit error rate is e to the -7. Of course, the post-FEC bit error rate would be 0. Samtec offers a growing portfolio of easy-to-use SI evaluation kits for testing many of Samtec's high-performance interconnect solutions. System architects and design engineers are interested in bleeding-edge performance, and this is one of several Samtec connector systems rated at 112 gigabits per second PAM4 that provide the designer outstanding design flexibility. For more information on Samtec SI evaluation kits, please visit samtec.com/kits. If you have any questions about these demonstrations, please contact us at sig@samtec.com. My name's Ralph Page. Thank you very much for your time, and thanks for watching.
There were fewer transitions and steps in that demo, but still very impressive. Another interesting thing about this Accelerate HP family is that a version of it is the connector interface for the standards for COM-HPC. The development of COM-HPC exceeds the demand for high-speed performance in embedded computing. COM-HPC coexists with COM Express specification, but provides the scalability and enhanced performance for the next generation embedded system design. COM-HPC supports two different module types. COM-HPC server modules are targeted for edge server applications. COM-HPC client modules support robust embedded computing. COM-HPC provides access to more system memory, up to 1 terabyte of RAM, and system flexibility for various computing engines like GPGPUs, FPGAs, and DSPs. These COM-HPC aligned connectors support existing and future interfaces such as Pci Express Gen 5 at 32 gigatransfers per second and up to 100 gigabit Ethernet. Speaking of PCI Express signals, this next demo is showing off PCI Express Gen 6 speeds at 64 gigatransfers per second. This HSEC6 family connector is compliant to the SFF TA 1002 and Gen Z specifications. Let's go back to Ralph to walk through this demo.
Hello, I'm Ralph Page, Systems Architect at Samtec. I'm at DesignCon 2021 and I'm going to show you a demonstration featuring a cutting-edge Synopsys chip and two new Samtec connector systems. The Samtec products are the new HSEC6 high-speed edge card connector and the new 70 GHz bullseye test point system. The Synopsys 6.0 PHY generates 4 64 gigatransfers per second PAM4 differential signals. This is a PCI Gen 6 data rate. These differential pairs route through an Isola Tachyon 100G test board to a Samtec 70 GHz bullseye high-performance cable assembly, the BE70A series. The signal travels from the bullseye connector through 8 inches of low-loss coax cable to precision 1.85mm Samtec compression mount jacks mounted on the first HSEC6 SI evaluation board. The signals then travel about 30mm in the board to the HSEC6 connector and then to the second evaluation board. The differential pair exits the second evaluation board through another set of 1.85mm compression mount jacks, through another 8-inch of coax cable, and are received back to the bullseye test cable system on the Synopsys board. The data routes back to and is recovered by the Synopsys PCI receiver. And the results really are excellent. The eyes are wide open, although the overall channel loss is actually 28 dBs at 16 GHz. The Samtec HSEC6 evaluation platform accounts for only a few dBs. The result of a bit error rate of e to the -8 is quite incredible. Post-effect would be 0, of course. Samtec has a variety of board-to-board SI evaluation kits which provide system designers and SI engineers easy-to-use platforms for testing many of Samtec's popular board-to-board connector products. Go to samtec.com/kits for more information about Samtec SI evaluation kits. Please contact us at sig@samtec.com if you have any questions about these videos and demonstrations. I'm Ralph Page at DesignCon 2021. Thank you for your time and thanks for watching.
These demos are all developed in-house with our system architects and signal engineering team. We try to incorporate real-world applications in these evaluation kits that are accessible to you. These Samtec-designed evaluation and development kits simplify the interconnect design process and reduce time to market for hobbyists, tinkerers, and professional engineers alike. Whether this is one of our popular high-speed mezzanine, edge card, and backplane systems, or high-density array systems, or, as seen in some of the demos, a Samtec high-speed cable assembly can simplify the PCB design and limit signal degradation in high-speed, high data rate applications. Samtec cable assembly signal integrity evaluation kits provide system designers and SI engineers easy-to-use platforms for testing many of Samtec's popular cable and connector products. Each kit includes the evaluation platform, calibration boards, technical documents, and test reports. Additionally, each kit is tested and verified by Samtec signal integrity experts before they go to you. Let's visit with Ralph one last time to see how Rohde & Schwarz use their vector network analyzer to run all 4 ports at 67 gigahertz through one of these kits.
Hello, my name is Greg Vaught. I'm a VNA product planner at Rohde & Schwarz.
Hi, I'm Ralph Page, Systems Architect at Samtec.
So we are at the Rohde & Schwarz booth here at DesignCon 2021, and we want to show you a really interesting demo that we have. So we've got a Rohde & Schwarz ZNA vector network analyzer. It's got 4 ports, and it goes all the way up to 67 gigahertz frequency. And we also have a calibration unit that we can use to calibrate our test setup. And you can see we've got 4 ports. We're making a differential measurement onto the Samtec evaluation board.
In fact, let's take a look at the back of this Samtec evaluation board. So on the back we can see that we have a Nova-Ray connector and about 18 inches of our high-speed twin-X cable going to another Nova-Ray connector. So this will be an example of a Nova-Ray to Nova-Ray flyover. That 18 inches of twin-X cable is a precision-mounted cable. So this Nova-Ray to Nova-Ray cable assembly uses a high-speed twin-X cable that is precision manufactured in the United States. That cable is about 18 inches long and it has only about 6 dBs of loss, despite it being 34 gauge. That gives it a really good bend radius if that's necessary.
And as I mentioned at the beginning, we are connected to the ZNA67 to the Samtec evaluation board. So we have a differential input and differential output measurement on one of the twin-X cables in the back. And I'll just walk you through these measurements really quickly. 2 of the key things we're showing here are the differential S parameters of the cable, and also you can see we've got a simulated eye diagram. And if you take a closer look at the S parameters, you can see the very low insertion loss that Ralph mentioned, along with really good reflection characteristics. And also in the bottom right hand corner of the screen, you can see we have a simulated eye pattern of a PAM4 modulated signal. And this shows you that with this channel going through the Samtec cable, we're not going to distort the real world high-speed digital serial signal. And so this is a good overview of all these important measurements for the Samtec device. And that concludes our demonstration. For more information on the ZNA67 or any of our vector network analyzers, please visit rohde-schwarz.com.
And for more information on Samtec evaluation boards, go to samtec.com/kits. This has been DesignCon 2021. Thank you very much for watching this demonstration, and thanks for your time.
We hope that through this series of demos, an introduction to tools provided by Samtec, we shared ways that you can design your system more efficiently. Whether that's starting at the breakout region as you go through the interconnect solution, or if you're using a Samtec flyover solution to extend your reach for your designs at 112 and 224 and beyond. If you want to see anything that you might have missed at the live event, go to samtec.com/DesignCon. Or if you have questions that are deeper into the signal integrity, reach out directly to our electrical engineers and signal integrity engineers at sig@samtec.com.